You know how much 14th is Pi Day? Pi is just a number, yet there's a whole day dedicated to it. In fact, two whole days because July 22nd is also Pi Day. I propose we make February 2nd Quadratics Day. What better year to start than 2025, a square number? For too long, quadratics are unfairly demonized. Sure, the quadratic formula as taught in most classrooms involve brute memorization, which is needed to some degree. But the formula does contain important information about the quadratic expression. It is also an opportunity for students to learn a key aspects of math, working on a problem in the general case so you can apply it to any specific case in the future. Not only that, when it comes to quadratics, there are other topics too. For example, projectile motion, quadratic residue, and quadratic surfaces, just to name a few. You can also use quadratics as a jumping off point to talk about even functions in general. Make that video, I will co-sign it. Before we start solving, let's address why we even try to use the quadratic formula to solve linear equations in the first place. There are two reasons. One, it is just fun. Two, when you have a formula that is more powerful than existing machineries, you should check to see if it is consistent with what we had. This is referred to in math as a sanity check. Now, a linear equation does not really have an x squared term, so we have to add a 0x squared in front. Using the quadratic formula, we get the expression x equals to negative b plus or minus square root of b squared minus 4 times 0 times c over 2 times 0. Not great. We have a 0 in the denominator. So in order to do this properly, we need to borrow tools of limits from calculus. The quadratic formula does provide a valid solution to the equation in limit form, with a caveat that we will get back to later. By the way, exercise for the viewer, on a grapher like Desmos, try to graph any quadratic equation, like for example, y equals to ax squared plus 2x plus 4. Note the a I said right there. You want the a to be on a slider, so you can slide around and see what happens when a is approaching 0. Anyway, to evaluate this limit, let's try to first plug in 0 to see what happens to the numerator and the denominator. When we do, no surprise, the bottom is going to give you 0. For the fraction to not give you an infinite and negative infinity, depending on the direction you approach a, you want the numerator to also have a limit of 0. And since the square root of b squared is the absolute value of b, we need the plus or minus the absolute value of b to have the opposite sign of negative b so that it will actually cancel out and give you 0. So we want the plus or minus absolute value of b to end up being plus b. This is going to be important later, so keep a mental note of that. Anyway, back to the solving. As we solve the limit of the fraction, we employ the standard trick to deal with radical expressions in a limit, which is to multiply the top and the bottom by the conjugate. Some of you might not have seen this before, but the opposite sign to a plus or minus is a minus and plus. We use the difference of squares formula to multiply it out. We have the square of negative b, which is b squared, minus the square roots of that thing squared, which will give us b squared minus 4ac. This allows us to cancel out the b squared via subtraction, and then we'll be left with a 4ac on top, which can also cancel the 2a at the bottom. So we are left with 2c over negative b minus or plus the square roots of b squared minus 4ac. Now, here is where we use the mental notes from earlier. Remember that we want the plus or minus square root of b squared minus 4ac to end up being plus b. This means we want the minus or plus square root of b squared minus 4ac to end up to be a minus b. So the denominator of the expression from earlier ends up being negative 2b. So putting it together, we would get 2c over negative 2b, which is negative c over b, exactly what we expected from solving that linear equation. And so we have found our answer. I hope you enjoyed this video, and thank you for watching. I do have another idea of another video, but I don't want to make any promises. I'll end this video with a happy quadratics day. Bye.